Hello, how is your morning going? We are on to day 19 of Advent of Code. And as usual, I have got the problem printed out with my Commodore MPS 803 printer. So let's take a look at what we've got. Okay, so there's 2 pages with quite a lot of black ink on it. So here's the message. Day 19, a penny. The elves of Gear Island are thankful for your help and sent you on your way. They even have a hang glider that someone stole from Desert Island. Oh, is that right? Since you're already going that direction, it would help them a lot if you would use it to get down there and return it to them. Well, happy to oblige. As you reach the bottom of the relentless avalanche of machine parts, you discover that they are already forming a formidable heap. Don't worry though, a group of elves is already here organizing the parts, and they have assisted. To start, each part is rated in each of 4 categories. X, extremely cool looking. M, musical, makes a noise when you hit it. A, aerodynamic. S, shiny. Okay, so 4 categories for Xmas. Then each part is sent through a series of workflows that will ultimately accept or reject the part. Each workflow has a name and contains a list of rules. Each rule specifies a condition and where to send the part if the condition is true. Workflows have a name and list of rules. Rules specifies condition where to send. Okay. The first rule that matches the part being considered is applied immediately, and the part moves on to the destination described by the rule. The last rule in each workflow has no condition and always applies if breached. Okay. Consider the workflow EX plus X greater than 10. Colon 1. M is more than 22. A greater than 30. R. Comma A. And then pipe. What is this? This workflow is named X and contains 4 rules. If workflow X were considering a specific part, it would perform the following steps in order. Rule Rx greater than 10. Yeah, there's some kind of formatting issue now with this printout. Maybe that's rule X greater than 10 colon 1. X greater than 10 colon 1. So maybe... Okay, so I have a symbol here. I don't really know what that is and what these are. Okay, so I have X greater than 10 colon 1. If the part's X is more than 10, send the part to the workflow named 1. Yeah, so these are... I think these are some delimiters that aren't being converted. So maybe this one is a little bit suspect. And this one is a little bit suspect. than these ones here. Well, the C64 doesn't have curly braces, so it would make sense if these were curly braces. Could that be the case? So if there's curly braces here, then those would show up incorrectly. Rule M smaller than 22. Otherwise, if the part's M is less than 20, send the part to the workflow named 2. 8 greater than 30. Okay. Okay. If a part is sent to another workflow, it immediately switches to the start of that workflow instead of, and never returns. If a part is accepted, sent to A, or rejected, sent to R, the part immediately stops any further processing. The system works. Well, that's not a sentence we read that often in Advent of Code. The system works. See here. Christmas is saved, the system works. But it's not keeping up with the torrent of weird metal shapes. Oh, so it doesn't work. Yeah, okay. Otherwise I'm thinking, why are we here? The elves ask if you can help sort a few parts and give you the list of workflows and some part ratings, your puzzle input. For example, okay, so here we go with the puzzle input. PX plus A is more than 2006. No, this. Okay, so this plus is not actually a plus. So that's something weird going on. So plus is not a plus. PX A is smaller than 2006. QKQ. Okay, so there are these rules. And then plus X, oh that's also that plus. I don't know what those are. Okay, so these are the inputs that are gonna go through this thing. This workflow. The workflows are listed first, followed by a blank line, then the ratings of the part. So this is the workflow. Then the ratings of the parts. The elves would like you to sort. All parts begin in the workflow named in. Okay, so there's an in here. In this example, the 5 listed parts go through the following workflows. Okay, so they'll starting in QQZ, QS, LNXA. Ultimately, 3 parts are accepted, adding up the Xmas rating. 3 parts are accepted. Adding up the Xmas rating for each of the accepted parts gives 7540 for the part with X. Okay, and then 462 with the part with the 236, yeah. 6951 for the part with this X. Adding all of the ratings for all of the accepted parts gives the sum total of 19112. Sort through all of the parts you've been given. What do you get if you add together all of the rating numbers for all of the parts that ultimately get accepted? Oh, I see, okay. So take these parts through these workflows until they get accepted or rejected. So accepted, accepted, accepted. So this is like a graph of a finite state machine. Like we have, what do we have here? So we have like, well, let's take this, we have this in state, and then if S is smaller than 1351, we go to PX state. Otherwise, we go to else, we go to QQZ state. And then QQZ if S greater than 2770, we go to QS state. And so forth. So these things form this type of this type of thing, and then accept and reject are like the terminator knows. So we need to walk this state machine according to these transition rules. Okay, let's start implementing. Oh no, let's not start implementing, but let's start downloading the puzzle input. 19. And let's see, actually, let's do this. So this is the puzzle. So I have these pluses and minuses. So let's take a look. PX plus, oh, not pluses and minuses, but pluses and pipe. Yeah, I bet those are curly braces. Okay. Well, that's fine. So this one, save to 9, 2023.example 19 txt. Okay, and then the puzzle input device 9, 2023.input 19.txt. All right. Again, quite a bit of saving to do. Cool. All right. So that's that. And the usual incantations. To get started, and then save the device 9, 2023.19 ACD. Okay, that's the thing. So then I cannot use fscanf. I wish I could, but I cannot, because it doesn't quite terminate these things properly. So so I'm actually just gonna use a infinite loop. then or actually, it would be nice to have a stable. No. Okay. So, our line. Get a line if S0, or actually let's do this, space S0 break. So this should now read all the workflows and stop in let's see if that works. So workflow, and then if I do another like this, and actually if I here I'll do this, I can go rule up, rule like this. So now I should be printing those things proper. Oh, I'm getting... Oh, I see, okay, yeah. And because they already have... Yeah, that's a weird feature of FGETs that whenever it gets you a line, it has the line, the end line terminator. Like the standard specifies that the line returned must include the end line terminator. I find that to be just absolutely weird behavior. Okay. Yeah. Cool. And now I need to do the states, the workflow state. So I'm gonna use a hash map for that. Struct workflow. Workflows. Let's say, how many of those? 2048. Actually, before I go on, let's actually see our input size. Workflows, rules. And then these workflows have these edges. Let's do a utility function here. Max edges. Und es how many rules they have, and I need to do a +1 here. Okay, and then printf workflows, rules, edges. Workflows, rules, max edges. Oh. Yeah. Yeah, that looks fairly good. So now I should be getting like a gauge of the the size of my input. 11 workflows, 2, 4, 6, 8, 10, 11, yes. 5 rules and 3 edges. Oh, the last edge is always like this unconditional one. Okay, let's run on the actual input to see what we have. Okay, that's a lot of workflows. A lot of workflows. Okay, now we're at the rules. Also a lot of those as well. Skip some printing. Hi Netboss, how's it going? Okay, so 508 workflows, 200 rules, and 4 edges. Okay, 4 edges. So that's a nice to be a fixed small number, so I don't need to do dynamic memory allocation for those edges, I think. And actually, if there's only 4 edges and the one is always the sentinel. Yeah, so basically 3 dynamic rules that have a condition. Okay, that sounds pretty good. That sounds pretty good. So let's see how we can go about it. So I don't need this calculation anymore. So I'll just nuke it. And we get 500 workflows. So if I do 24, that should be enough for my hash table. So then the occupancy is going to be about 50%. I mean, or why not? We don't really need the need the memory. At least that I could figure out. And then so each workflow has a name. Oh, now I didn't actually get what's the maximum name. Let's say they're They seem to be 3 characters. Let's hope that's the case. So I'll just use a string of length or 4 chars for this one. And then I need the rules. So the rules contain an attribute. Let's do rule. What is a rule? Rule contains an attribute. So that's one of those Xmas things. And then it's always smaller or equal to. So less or equal or less than Boolean. And then there's the limit. That's a rule. And we have rule R. We have 3 rules. Oh, and then of course a rule has the workflow that the thing goes to if the if that thing matches. And then there's that workflow that is the let's say the end state. Okay, I don't need this string count function either. So this should be a suitable representation that I can think of. And now I need to do a get char star by name. So I need to hash that name. U16 hash equals. So my hash is now 11 bits. So I would be taking the name. Name 0 XOR here. No, what am I doing? N0 hash U16 N1. Let's shift so I had 11 bits in my hash, so let's left shift by 3. And then to left shift. Well, let's do this one and then this 3. That shall be my hash. And then while workflows page, while string compare workflows page name with n, workflows page to sorry name 0 and so linear probing, while that has a name and then it's not this one. Actually, no. Well, let's do it this way. If not this, return H. And then otherwise H equals H plus 1 and 2047. Yeah, actually, let me change this into, let's go 3 and 6 and 2047. Maybe, or whatever. I imagine this is not gonna matter too much because we only need this hashing while we're building the whole thing. Like this is only used at the very beginning to connect up these nodes. So actually this is cropping. I should have a rotate function, but whatever. The C64 actually has a rotate instruction. It would be nice to have like an intrinsic. There probably already is an LVM intrinsic for rotate, but I don't quite remember what that was. So here. Okay, so now I have a way to. Oh, and then string copy workflows page name and so this is what I screwed up in what the other day. Like there was that earlier day when I tried to do a hash. I think it was like 4th day or 3rd day or something. And actually, if string length n is greater than 3. So let me just add a check here. So this whole fixed length scheme doesn't blow up on me completely. Okay, and now I need to parse parse workflow from an input line. So that's what I do here. Parse workflow from an input line. And then here parse rule from an input line. So I'll have these functions to implement parse rule. Perfect. Okay, so yeah, so this is gonna be a little bit of manual manual work. Char star e equals s while is alpha star e plus e star e equals 0. Workflow w equals get s. Section BSS will not fit in. What? Section BSS will not fit in RAM. This is 4 bytes. Oh, this is actually pretty big. Now I understand. So this is 1, 2, 4, 6 bytes. So this is 18, 22, 24. Oh crap, I'm actually 24 times 2 kilobytes. Yikes, okay. That's actually more than I I realized. So this static array of 4 rules. I could do this as unsigned 2 bits and this is just 1 bit. So I could pack these into the same byte. But now this fits. So 124 and then I need to okay, now I'm gonna do this. Yeah. Well, that was unexpected. Okay. So now I have the workflow name. And then I'm gonna do, okay, s equals end plus 1. So I'll parse the name of the line or the thing. And E was at that weird character. Maybe that was a open brace, like a curly brace. S equals E plus 1. And then I need to parse. So it's always one character that is the attribute. So while s star s actually s1 is either smaller than or s1 equals greater than. So as long as I have these rules to parse, rule index equals 0. What was it? Rule, yeah. Nope. I'll get rule r equals workflow. Was it rules r rule index plus plus r attribute or attribute less than limit destination. Attribute less than limit and then destination. So attribute is U8 parse attribute ch. If ch equals x, return 0. If ch equals m, return 1. If ch equals a, return 2, return 3. Or actually, let's add if ch equals s, return 3. Just to make sure parsing stays completely right. Parse attribute S1. No, S0. Less than is S1 equals less than. Limit is from ASCII to integer S2. S plus 2. And destination is get stir S colon plus 1. All right, that looks about right. Hello, Kim Pungsa, how are you doing? Am I pronouncing that right, Kim Pungsa? Welcome to seeing me struggle on the C64. Okay, and then oh, before I do this, yeah, now this is not right. This is not right because this is now looking at this S unterminated. Oh, and actually that makes me think this hash function is also this is not correct. Well, let me just do it. Char C equals N1, then N2, otherwise 0. Okay, now it works. Yeah. Assuming the lengths were all 3, but we'll see if they are. So how do I delimit this string? So char name equals this, and also while is alpha e star e plus e star e equals 0 and s equals e plus 1. Okay. Okay, now maybe that works. Or maybe it doesn't. So that's parsing the workflow. Yeah, let's give that a go. Printf workflow %s and workflow name. Then printf t smaller than or u smaller than u on to sync S. So rule. Oh no. This is, we can see. Rule attribute rule less than, then smaller equal, otherwise greater than equal. Rule limit, and then finally rule DSD name. Let's work on the example for a sec. Okay. Okay. So let's see what this one does. Workflow key X mass A smaller than 2006, then go to QKQ, M greater than 2090, go to A. Oh yeah, and then there's that sentinel. Reject. Yeah, this looks alright. Last one, HJJG M greater than 838, accept. Yeah, okay, this should... Yeah, this looks all good. Cool, okay, so then the sentinel state. So I need to do this. And then the workflow end equals get S. Oh, actually E equals S. And then we have end oops, actually now yeah. I may have done something there that my editor didn't quite like, so I may have actually corrupted the internal memory of the editor. There was that bug about like deleting lines that I have fixed, but I forgot to upload the fixed version. So that's gonna be interesting to see if something happens here. End PV, end R, end RFG, yeah. Okay. So I'm gonna run this on the actual input now and see how it behaves. End A, end R. Yeah, it's printing. Everything seems to be 3 characters. That looks fairly good. Accept, reject. Accept, reject, yeah. Lots of values there. Everything only has 3 rules at most. Seems pretty good. Seems pretty good overall. Okay, I'm gonna make an assumption that there aren't any more. I don't want to wait for all of this. So, oh, and yeah, stopping execution in the middle of disk I/O. I find that the C64 likes to crash there every once in a while, so that's a little bit annoying. But well, anyways, so then it's on to parsing the parts. So the parts are, yeah, 9, 20, 23.17, no, 17, 19 ACPP. Okay. Okay, so parsing. Parsing rules, parsing parts. Let's do parse part. That's a nicer name. And that goes like... I need a structure for parts. There are 200 of these. Struct, part, that equals U16 value for parts 201. U8 N parts. Part P equals part N parts plus plus. And then I'm gonna assume it's always in the order Xmas. So while not is digit star s plus plus s, p value 0 equals ASCII to integer s. For I at I equals 0, I is more than 4 plus plus I. Printf x m a s. Cool, okay. That might work or it might not. Let's see. Seven eight seven 28. No, what? So it's printing, parsing all the same characters. Why would that be? Oh. Let's double check that. Okay, no, that was an editor bug. Actually, that was a desynchronization. My code was correct. Yeah. So that's an issue that I haven't quite had time to fix, but okay. So now that works. 2876, then 13. Yeah. Cool. Okay. Yeah, that's an unfortunate editor bug. So now I can get rid of all of these debug prints. Yeah, this is not the nicest code. But the C standard library doesn't really give you much better options either. Yeah. Last one, I think. I'm not completely sure. Not completely sure what that refers to, but maybe I'll figure out. Okay. And then I'll take all the parts. So I'll go for U8I equals 0, I smaller than number of parts, plus I. And then part E equals parts I. And if accept part P. What was the question? The question is, let's do U32 directly. The question is sum of ratings. Ratings plus equals PV0 plus PV1 plus PV2 fit plus PV4. You don't quite fit. You can go like this. Printf accepted. Let's just print the first one, PV0. Printf total ratings or sum of ratings. Cool. All right. And then I just need the accept function and I should be all done. I should be all done. So, bool accept part key workflow W equals get in. Oh, no, not this one. Get. This one. Get in. Workflow accept equals get. Actually, let me do workflow start equals start accept reject. Equals start. So here, before I do the accept, I'll calculate start equals get in, accept equals get a, and reject equals get r. PV2, PV3. Ooh, did I do a mistake? Maybe you spotted a mistake. That's probably the case. I'll see that in a moment. Maybe. Okay. While W is not accept and W is not reject. For you, a rule equals 0. Rule is smaller than 3 plus rules. And then I need to match the rule. So. Let's go up, refresh my memory. Other less than limit destination. Other less than limit destination. If actually rule R equals W rules R. Less than if key value rule attribute is smaller than limit, we go to we go to the rules destination, and then we break doing this rule. Can I make this a 1? It's kinda you come here, or not rule less than and attribute is greater than limit. Then you go to the destination. Oh, and break. That's a lot of nesting. Yeah, certainly there's room to clean this up. Oh, and now the save crashed. No. No, I wrote so much code. Crap. So now this is crashing again on save. Ay. Ay. Why? I had a hypothesis that this crashing on save would happen when the disk was nearly full, but that's not quite the case. P.v2. Oh, did I did I have something incorrect there? Oh, thank you so much. Yeah, that was a yeah, that was a silly typo. Ay, that would have... Yeah, that would have been an incorrect answer right there. Okay, but now I lost my accept function and pre-computation of these things, so... Oh. Okay, so... Star equals get in, accept equals get accept, reject equals get reject. And then I'll have, actually, why am I on memory? 6 kilobytes. I'll put it here. Start S, start accept, start reject. So those can go over there. And then I get to write that bool accept all again. Bool accept part key. Let's try to be quick about it. Okay. Okay. So just don't keep crashing on me, please. Okay, so workflow W equals start, while workflow is not accept and workflow is not reject. Actually, workflow is, let me do another function here. Workflow's destination, workflow and part. Yeah, let's do this instead. So I I avoid that massively. Awkward super nesting. And then for I8, I equals 0, I is more than 3, plus I. If, okay, and then I do want to do rule R equals workflow rules I. If rule less than and key value rule attribute is smaller than rule limit, return rule destination, and if not less than an value rule attribute greater than rule limit, return rule destination. Return rule end. Return workflow end. Yeah, this reads much better than the one before. And then return this one equals accept. And did I still not have get bonus jar? Okay. Okay, now I think it's all done. It's all written, there's no bugs, it's perfect. I'm gonna run it and I'm gonna get the star. That's what's gonna happen. I don't need to do any debugging today. Especially not for 2 hours like I did the other day. So, hi there, are you doing part 1 right now? Yes, I'm about to run the code for the first time on the example input, which gives me an infinite loop. Oh, for fuck's sake. Oh, for fuck's sake. Okay. An infinite loop. Where could I get an infinite loop? That's interesting. Okay. I tried to manifest a working code on the first try, but apparently that didn't happen. That didn't happen. Why would this? Run into an infinite loop? So let me do here. At least this one to debug. Parse workflow. So that's not the infinite loop. The parsing is not the infinite, but this one. Destination. This cannot be an infinite loop. This cannot be an infinite loop. So that only leaves this one. That only leaves this one. Let's see where this is cycling. Where are you cycling? Okay. Where is this thing cycling? Or can I have here? No, this one also won't have an infinite loop. Okay, so it's... Does it handle A and R correctly? I hope it would, because I do get those A and R states here, and they are uppercase A and R. But I could have something wrong with the build-up of the graph, so let's see now what happens. Okay, so I'm going into some completely corrupted memory. Oh, now I know at least one issue. Workflows. I don't store the number of rules. I don't store the number of rules. So I'll do like 0 means invalid, 1 means less than, 2 means greater than. Yeah, that's that's at least one bug. Okay, so here less than, then 1, otherwise 2. And then here less than equals 1. Actually, if rule less than break, less than equals 2. So those, I think what would have happened is that would then have returned null destination pointer here. Or I guess I could store here the number of rules, but that would be one more byte into my memory. So this one is basically getting it, like using this kind of thing. Fits in the existing memory footprint. And now let's see what happens. Sum of ratings 19114. Okay, so that works on the example input. Does the C64 not trap on null read? No. No, it doesn't. The only way it traps, like, the memory address 0 is actually a valid memory address to configure the CPU port. Like, the memory address is 0 and 1 configure the CPU. So that's a fun one. But the only way to actually, like, hang the CPU is to jump to an illegal opcode that doesn't decode to anything. That makes it hang. I think, at least on the emulator, it hangs. So I believe that would be following the actual device. But anyways, okay. So now these workflows, I can remove my debug prints. You can go away. Did I have any other debug prints? Did I have any other debug prints? Added and accepted. Okay, so added can go away. This one can go away. But I do want to print out what I'm accepting. Just for... ratings. Just to get a sense of where this thing is going at. So... Okay, so that was basically one bug that needed fixing. Otherwise, it was on the first go. Hopefully, hopefully. All right, and let's take it out for an actual run. and see what happens. So first it's building the graph while the border is blinking. And then it starts walking one. Oh, now I actually realized that I used too much. Like, why did I build even an array of these parts? Because I could have accepted those immediately while I read them. So if I needed to save memory, I could have just skipped having a list of parts in memory at all. I just need the graph. I believe this disk drive reads somewhere between 100 and 300 bytes per second. Okay, and now it's accepting. Cool. That looks like a nice number. Sum of ratings 395,382. 395,382. Okay, let's try to submit. Looks like the correct order of magnitude. Well, okay, yeah. Yeah. Let's see. Where is it? Day 19. Answer 395,382. And is it correct? Is it correct? It is correct. Nice. Oh, first try answer. That was fun. That was also quite a lot of code. Like, this wasn't a small program, and the only thing that saved me here was that I was able to optimize the memory usage of the editor. So I have considerable more memory for the document. I think, like, if I had the version of the editor that I had on the first week of AOC, I wouldn't have been able to write this code at all. So that's pretty nice that I was able to manage such a big program code in the editor. Congratulations. Well, thank you so much. All right. So in part 2. Are we doing cycles? Like, is there going to be a cycle problem, or what's going to happen? Okay, so I'm going to put the printer to the work. Basically, I'm painting this part, and let's see what comes out. Let's see what comes out here. Well, that wasn't too much text at all. Just a couple of lines. Actually, that does sound kind of ominous. Oops, what happened? Oh my god, all my paper fell down on the floor. Okay. Part 2, just a small slip of text. Even with your help, the sorting process still isn't fast enough. What do you mean? We have the Commodore 64. Of course it's fast enough. One of the elves comes up with a new plan. Rather than sort parts individually through all of these workflows, maybe you can figure out in advance which combinations of ratings will be accepted or rejected. Each of the 4 ratings x can have an integer value ranging from a minimum of 1 to a maximum of 400. Of all possible distinct combinations of ratings, your job is to figure out which ones will be accepted. And in the above example, there are, oh my god, there are like 1,000 million, billion, 167 trillion distinct combinations of ratings that will be accepted. Consider your list of workflows. The list of part ratings that the LS wanted you to sort is no longer relevant. How many distinct combinations of ratings will be accepted by the LS workflow? Okay. Okay. How did they get that many? Wait. What if my input directly goes to accept? How many parts will be accepted? That means that all of that's 4,000 to the power of 4. So that's 256 million, billion, trillion. So about half, in the example input, about half of the rules get accepted. That's interesting. Okay. Okay, so here's my approach. Here's my, 4,000 to the power of 4, yeah. Here's my approach. I'm gonna have this state. I'm gonna have this state of all the ranges for x, 1, 4, 4,000. And same for MAS. So this is my packet of information. Then my input thing is gonna have multiple edges to it, right? So there's gonna be multiple things, and I'm gonna send this packet through all of these rules. So I'm gonna have these nodes, and all of these rules, they're gonna clip part of this range away. So I would then have like, oh, now my only through, like after this, like m needs to be smaller than 2000 and 2001. So then I would have like m2000 here. So I would be entering this state with this rule. So I get to these states with this kind of mechanism. And then eventually, so let's say this M2000 thing has come with this kind of packet. And then I would have an accept eventually. So then I can calculate, multiply all this. How expensive is that type of printer paper? I bought a big stack. I don't remember how expensive it was. it was the shipping. Like, it was the shipping, because there are somewhat few places you can buy those. So I bought it from Amazon, and it came from the US, and then I had to pay customs, and like, it was so hard to find otherwise. So I think that's the type of thing that makes it more expensive, but it's still being produced today. Okay, so yeah, so I have these rules. They all flow to accept eventually, and then I get the answer. But there's a gotcha. So if I did this and I get a revisit. So if I have input goes here and then it goes here, like, this rule might be super constraining. But then I get to do this, which might be less constraining. So I get to a new state, or the same state with this, with the with two different rules or two different packets. Oh, I cannot combine them. I actually cannot combine them, because they could be like very disjoint. They might be like completely different ranges. So so I'd have to use more state, because like one of them might be that M must be in this range, and the other visitor to that state might say like M must be like this. So I'd have to have like variable amount of memory to combine those. That wouldn't be nice. But what if I just do the naive clip approach? I don't need to even think about combining. I use this, then I visit all the edges, then clip, then visit all the edges and clip, all the edges and clip. Surely some of these things form cycles. What is it with AOC and cycles? There's always cycles in these problems. How many states did I have? I have 508 states. So the question is, can I track where I've been? So no cycles. It might be helpful to know that the workflows form a tree, no cycle. Oh. I see. Okay. Well, then this is gonna solve it. Okay. Well, let's give that a try. Let's give that a try and see what happens. So let me save this first for the A part. And And then let's save it again for the B part. I wonder what the depth is gonna be. No, they all start with 508. So if I have 508 weights, then yeah, they're not gonna fit in my like regular C64 call stack. Okay, so what I'm going to do is have a struct packet which has U16 min max. And I'll start with a packet P that is oh no 111 and then 4000. But I do need to consider disjoint ranges. Yeah, I totally do need to consider disjoint. Oh, I'm the wrong camera. Oh, sorry. No, sorry. Yeah. So the tree is really shallow, at least for my input. Okay. So yeah, so I do need to consider ranges. Well, let me do first before I calculate. Let me just accept. I'll just walk this through the graph. Node star workflow equals S. And I will have no workflow. So and every packet is at some workflow node. S. And actually now let me nuke that whole. So I don't need to parse the parts anymore. You can go away. part can also go away. Destination for a part. That can also go. I'm gonna be re-implementing this. Yeah. So I don't need this. And bool accept, I don't need this either. Parse workflow I need. Parse attribute I need. And to get I need. Okay. Oh, and I get a crash. Darn, this is the trickiest issue. Okay. Okay, let's give that another go. Well, I just deleted code basically. I just deleted code. Uh, 19B CPP. So this one I need. And this one I don't need. And this one I don't need. And this one I didn't need. And this one I didn't need. Okay. Let's save again. And I don't need to parse the parts. And I don't need this loop. Let's take that away. Okay, so that's where I'm starting from. Huh? Okay. Saving wasn't oddly functioning. Okay. So I'll have a packet to min and max, and then I'll have a workflow where they're at. So that's what I'm working with. And then I want to have a stack of these. And stack pointer. And then I'll do just like I did the other day, equals ones 4,000 and then start. while stack pointer greater than stack. Packet P equals star minus stack pointer. Okay, so that's what I'm going with. And then I'm going to process, so for int I equals 0, no smaller than 3, plus I. Ooh. I just realized. Well, let's see how this works. So I have the rule R equals packet flow rules I. If rule less than, let's say rule less than equals 1. Let's first do this case. Less than equals 1, so that's smaller than. Then I have packet P2 equals P, P2 maximum of rule attribute must be rule limit minus 1. So I have this attribute clip away the thing and then P2 destination equals P2 flow equals rule destination. SP++ equals P2. But then the thing is, I need to create, okay, so that's interesting. So I have this packet, so now I need to form, oh, okay, I see. I need to change the minimum of this existing packet on this attribute to be our limit. But this only holds if P2 min or the attribute is smaller or equal than P2 max on this attribute. Because if I'm broken this range, so it's now like negative, then I don't do this. And then if I've broken this range, if P min. Oh, I don't like my indexing here. I need to change my indexing if I'm gonna make this work. So actually I do need a range. U16 min max. Range. Let's do range X for Xmas. So now this becomes 4,000, 1, 4,000, 1, 4,000, 1, 4,000, and then S. No. Why wouldn't this work? So let's do range R equals 1, 4,000. R, and S. This should work. Yeah, okay. Not quite sure why that would work, but then okay, rule, and now I get to do range X equals R X rule attribute. No. P dot packet X attribute. Yeah. X. Oh, I'm still having. Let's do range P2X equals P2.X R.attribute. So then I can do P2X dot maximum. And then I do P2X minimum is smaller than P2X maximum. And then I do X minimum equals R limit, and if X minimum is greater than X maximum. So if I've broken this range, it's now become disjoint or like negative. Then there are no more elements to follow any of these rules, so I continue. Or no, I don't continue, I break. Actually, I need to break from that very last unconditional case as well. Let's see. Okay, well, I'll figure that in a moment. Else if R less than equals 2. So this is a greater than thing. Let me just write this by hand so I can think of this too. So I'll create a new packet, P2 from P, which has been filtered in a previous stage. And then I have range P2x equals P2's range for that particular attribute. And because this is now greater than, I'll need to bump up the minimum. Greater than, so it must be at least the limit plus 1. And then where they go to this destination. And if this range actually now exists, put it in P2. And then for the original range equals our limit. And if I've broken the range, we stop. Actually, yeah, no, I need to do, yeah, I'm gonna do this if I equals 3 or not alt LT. So if I'm on the last rule, everything unconditionally goes packet P2 equals P. Well, everything unconditionally goes to the destination of this rule. This workflow. Okay. But the thing is, so if packet workflow equals reject, continue. So skip all rejects. If packet workflow equals accept. So I think naively I would be doing now this. Sum plus equals packet range packet range 0 max plus 1 minus packet x0 min. Well, what am I writing? x0 min. Actually, hold on. Here I can do this. I can do this. No? Member reference base type. Packet X. Oh. Okay, yeah. And then I'd like to do this. Isn't 64-bit arithmetic hilarious to slow under the 6P02? Yes, it is. It is. But that's what we're going for. It's not a 6. No, well, it's a 6-5-10, but that's essentially the same. It's just it doesn't change from the programmer's perspective. It changes from the hardware wiring perspective that they did a change for. But I think there's a possibility that this is just wrong because this doesn't account that these ranges that get accepted may overlap in the result. So there's that. But let's see what this runs for the example, because maybe those have been crafted suitably. Printf some yeah. So. PSS will not fit in RAM. Yeah, I did a too large. This stack is too large. Invalid conversion specifier. Oh, this is a conversion bug. Yeah, accounting for large range overlap was the hard part for me. Yeah. So I need to queue up the accepted ranges. Or do I even need to sort them? Probably only need like 8 stack slots. Okay, but we'll see. So what happens with this one? So I should get a value that is too high compared to this example. Oh, did I run the... Oh, did I run on the big input? I maybe had the big input file, so this is gonna take a while. We'll see. Hi there, what are you working on? Oh, hi Twitchiger, how's it going? I am working on the Advent of Code Day 19 puzzle part 2 on Commodore 64. Whoa, well that was a quick crash. That was a quick crash. 19 already, very good. Yeah, that's today's puzzle. So right now trying to crack that one. 2023 19B CPP. That was a crash. That was a crash. Yeah, I was on the input. Okay, so here, if SP is greater than stack plus 400, printf I'm out. So let's make sure I don't blow that one. Okay. What happens on the example? I'm out. And sum is something huge. What did I do wrong? Subtract the stack pointer. I from 1 to 0, 1 to 4, or 0 to 4. Oh, actually. Well, I take to a reference to something that might not exist, but that's fine. That's fine because I don't dereference. No, I do. I totally do. Okay. I need to do if I equals 0 or 3. I need to do this. Let's add a break here. Ooh, else if. Okay, that was the issue. That was my issue here. Yeah, missing an else if. Well, yeah, I can see how that would have blown up the stack immediately. Okay, now let's try to. I'm out. And some doesn't even print. Oh, this also needs to break. Why don't I break here? That's an issue, yeah. And I crashed. Ooh. Let's add some debug prints. Let's add some debug prints. Something is not quite going up to the expectation. Something is not going to the expectation. So... oh, if it's an accept. Continue. Oh, now I'm missing all sorts of things and break. Okay. Yeah, this code is a little bit of hairy duplication. I think I need to collapse this to one block, but that can wait. Okay, let me run to see if that was the issue. That was the issue. And wait, I get the right answer for the example. Oh, are they being sneaky and they don't show that range overlap? I get the right answer. Well, I'm just gonna go fishing. If the example works, I'm gonna go fishing. That's weird. No, I got the wrong answer for the yeah. Until I fix my code, that is. I'm surprised. I'm totally surprised that I got the thing, but but yeah, if these ranges ever overlap in the accept nodes, this is not gonna work out. But yeah, this is a phishing answer if anything, because I still know that there's this potential problem. But yeah, I guess sometimes it's nice to go fishing. I think you already correctly split the ranges, so no overlap. Well, no, I think you might have distinct ranges that... I mean, I guess it depends on how the... Okay, I get a huge number. How the input has been constructed, or the graph. So we're now going fishing. 103 557 657 654 583 103 557 657 654 583. Okay. Okay, let's give this a try. I'm thinking like different... Yeah, like different branches of the thing might have like rules that come to overlap. But let's see. 103 557 657 654 583. 103 557 657 654 583. Is that the right one? Oh my god, it was correct. It was correct. First try. Oh. I am not completely convinced why that is, but maybe, yeah, maybe there is some special property that, because I'm thinking if one branch of this kind of thing would clip differently, and then they flip the other way around, like in a child node, they would clip in a way that would kind of leave an overlap. But maybe maybe that's not possible, or that wasn't in the cards. I don't know. But it works. So I'm super happy. Congrats, thank you. And this feels really good because this was like the perfect day. Both parts solved on the first answer. Both parts solved directly on the C64. I didn't need to go to the PC to debug. I've had to do that on a lot of days. to go to the PC, double check something. Like yesterday for part 1, I had the correct solution. I did a flood fill for the most tricky thing, and then I just had a simple integer overflow that I just overlooked. So today I didn't have to give up, I didn't have to bail out to the PC, but just persist with the C64, get the both stars, and yeah, the code, let's double check what we see on the advent calendar. It's all messed up for us. It's all messed up because all of this is the lava. These pipes are the lava. And I think these arrows are the snow that you only see on PC, but they come out. They bug out this thing. Why no day 14? Oh, this is just a bug of this. So I'm reusing a command line client that somebody else wrote in Rust. So I didn't do my own like command line client for Advent of Code. I'm reusing an existing one, and there's some kind of bug that on every day, like if I go to last year, on every day it doesn't print the stars for the topmost line. And I think it's got something to do that line is kind of like a multi-line thing. So if I go here, I do still see the 2 stars that I got. So I have solved so far all the problems using the C64. But yeah, that's just a quirk, and I'm not gonna bother too much about it. So that's gonna be fine. I mean, this is quite the mess already with these other things going on. And oops, and I couldn't get back to my editor, but yeah, that was a lot of code to write today, and I was positively happy that the editor was able to keep up. I don't get these out of memory errors anymore, even with such a large input, because I was able to optimize memory usage a little bit. So that's pretty cool to see, that didn't become a blocker for today. But in any case, the elves are now processing all those gears super fast, and I think that's everything for me. 2 hours and 20 minutes I've been online, so I think I'm gonna conclude here, go get some lunch, and then see some other solutions that people wrote, how short they could make it, and I'll try to clean up and simplify my solution, and I'll write in the blog in the evening about like the final code that I ended up with. Cool. Okay, so that's everything for today. Thanks for hanging around, and yeah, see you like the usual then on tomorrow's puzzle. Take care, guys, and I'll see you later. Bye.